Hello. Well, good evening. Welcome to NeuroNet presentation. This is the first live stream, so please be patient with me, as this is the first time I do something like this. And we're going to have a 10 minutes talk on artificial intelligence and neural networks. Let's see if you can hear me. I'm not even sure I can read the chat, but I'm pretty sure you can see my screen. So I'll give it a couple of more minutes before we start. Just for my colleagues from NeuroNet to please tell me, give me a nudge if you can hear me. Should be okay. So far one person is connected. Let's see if we get a few more before we start. Okay, sorry, I'm not going to do any singing tonight. I'm just going to bore you with some information about artificial neural networks. So 2 people connected. Maybe we'll wait for a few more. Otherwise, I can get head start. Well, maybe in the meantime, I can talk about NeuroNet.blog. So NeuroNet.blog is an initiative of myself with a group of friends to share with the world more information about, knowledge sharing of information and usage of artificial neural networks and in general artificial intelligence. Usage in businesses, big and small enterprises, but also for personal projects. So we want, because artificial intelligence is so widely used these days, we would like to help people develop their capabilities. As we know that now it's a lot of programming blocks are already available on the internet. You can go to Stack Overflow and program simple neural networks really within like an hour. So it's become like common knowledge. So there is no reason why this knowledge needs to be kept with super experts, academic people, and it cannot be used by everybody. So the objective of NeuroNet.blog is to share knowledge and to advise one day businesses on the use of neural networks, artificial intelligence, and why not, help them achieve their goals, by training people. But we're still at the beginning of this process. So for now, we on our blog, there is a number of different articles that will pique your interest and your imagination, I hope, on this topic. So I say you can give another couple of minutes. Anyway, this live stream will be recorded and will be available after, so you can watch it later. And this is going to be a regular event. So possibly every couple of weeks or every week, we're going to have 10 minutes to talk about artificial intelligence and neural networks. Let me just give a quick check on LinkedIn to see if there's anybody that maybe has the old link and cannot connect. Maybe is struggling. Or otherwise, we're going to start. Anyway, we're going to have these every week. So there is nothing to worry about. You're going to catch this later. So we're going to start now. Let me just reopen the stream. Yeah. Okay. So let's get on with it. I say 3 people connected. Good. Maybe they're all like friends and family. For the NeuroNet, if you want to read about the articles on NeuroNet, we're soon going to have a new website. But for the moment, you can connect to www.neuronet.blog. Anyway, if you found this live stream, you probably know the blog already. So I say let's get started, and then maybe more people will connect as we go. So I didn't prepare a presentation specifically for this purpose, but I'm going to show you some slides and some material that I collected. So what is artificial intelligence? Well, artificial intelligence is, well, whatever you want it to be. It has to do with the mimicry, so to technology systems that mimic human behavior. Now, the degree of this mimicry, it depends. And of course, there is a lot of official definition of artificial intelligence, but I don't believe in any one of them because it's a field that is expanding. So, as I said at the beginning, really, artificial intelligence is whatever you want to include in it. I put some pictures here of what comes up when you think about artificial intelligence. Some people of my generation will think about some kind of catastrophic scenario, with the machines taking over the world. Some other people will think about the more philosophical aspects when machines are going to be like people, and they're going to be better than us, and they're going to replace us, or they're going to be helpful aids in our daily life. Or some people might have watched the videos from Boston Dynamics, about the dancing robots, in the last, it came out a few months ago. Anyway, so let's get on with it, and then let's go to the topic. So, AI basically it's a combination of different disciplines. There is the artificial intelligence itself, which is connected to deep learning, machine learning, computer vision, robotics. So there is a lot to it, and basically it's all the technologies that enable to have such a degree of automation that comes close to human behavior, in some cases even better. I'm not going to give you the academic definition of AI because I'm not an academic, I'm an engineer. And as an engineer, I think about how to use AI to develop successful products. I don't really think about it in terms of, theory, but more like how to implement it in practice. So this is 10 minutes presentation, so already took 5 minutes. I'm going to speed up a bit. So artificial intelligence, machine learning, deep learning. Well, to make it brief, these are all subsets. Deep learning, machine learning are subset of the same topic. You can organize it in this way. You can organize it in different ways. The bottom line is that machine learning, deep learning were developed only in the last few decades, and deep learning is a very recent thing, and they have to do with machines that do operations without being explicitly programmed to do them. They learn from where? They learn from the data. And then we can go on to data. So you may have heard about data science or data analytics. Well, that's strictly connected to artificial intelligence and neural networks, because the data are the main source for the learning for a computer, really, for artificial intelligence. We have different kinds of data, structured data, unstructured data, and then in order to, there is a process of labeling that we're going to see in a moment. So structured data basically are the data like a balance sheet or a list or a roster of people. So where the data, what they mean, we know for every information what it is. For unstructured data, instead, it could be like something like pictures. You may have a group of pictures, but the computer will not know what they are and will not know what's in the pictures. Because when we identify what's in the picture, we use our own human neural network to determine what's in the picture. So that's already a process. There's already a network there that is working. Labeling is the process of actually turning unstructured data into structured data. So to give a label to every piece of structured information we have. I'm going to go a little bit faster because this is a quick thing. Machine learning, there's different type of learning. So basically machines that use the data to perform autonomous operations. Supervised learning and unsupervised learning. And the difference is that while in supervised learning, the machines learn from large amounts of structured data, like problem of classifications and prediction. Unsupervised learning is when machine learns from unstructured data. And then we can have all variations in between. I think we can talk about a little bit more about neural network at this point, since you're already 8 minutes in. Well, just a moment before we get there. How can be usage of AI? Usage of AI, neural networks are a subset of AI, are a technique within AI. So it can achieve the same things as AI can achieve. So uses of AI are for robotics, speech recognition, knowledge extraction, feature recognition, and well, you cannot see it in the slide here, but I put something about real-time adaptive virtual reality experiences, which is a bit of cutting edge to have virtual reality experience adjust based on your reactions. But basically, it's about using great deal of information to perform autonomous operations. I don't know what about. Yeah, that's it. So the virtual reality headset would adjust your experience based on data collected from your body. And then this is also an interesting topic. So Alan Turing developed the Turing test. Well, all the way back to before World War II, and that's basically a simple test to understand if an artificial intelligence is it's an artificial intelligence by comparing it, by a process of interview. So if you're able to interview an artificial intelligence and be fooled into thinking that it's a human, then the artificial intelligence is and this is passed the Turing test. I also put in this slide the picture of the robotic lady that creates arts to an artificial intelligence, which to me is quite an interesting example of how artificial intelligences in a robotic form can be creative. Let's go to the main topic. I know 10 minutes are very short, so we're going to go to a little bit more about neural networks. So neural networks. So I need to put the document up, but you should be able to see it. So basically, there is a similarity between artificial neural networks and your biological one, mainly from the structure. Sorry for the Italian. This is a draft of our book. It's going to be published in a few months. But basically, the structure of a neuron in a human brain or the biological brain, it's somewhat similar to an artificial neural networks, but only from the outside. Really, it's only like the structure. So it's like the atomic model shown as a solar system. It's just like a little bit of an analogy. What can a neural network do? What do we use it for? Well, for instance, let's see. Let's go. It can be used to identify from a picture if the picture is a dog or a cat or anything else. Because as we said before, how does a computer know if in a certain picture we have a cat or a dog? We'll not know it. We'll read a lot of pixels. I don't know if I have the picture of there. We put somewhere in our book like the cheetah and the leopard, and how you make them apart. How can a computer make them apart? These are things that can be sorted by a neural network, an artificial intelligence based on neural networks. So a computer vision system, sorry, new word, computer vision, it's actually something that will translate this picture, this image, will read the pixels line by line by line by line and translate it into the RGB values, so a value for each color. So this is through these numbers, this is how you discretize this picture into numbers. And this is what the neural network is going to read, and it's going to give an output. Now, so how is actually going to work? So for instance, this is a typical classification problem. Is this a dog or a cat? And this is something a neural network is very well suited to do. There are also other problems, like a prediction problem. Let's predict the value that Bitcoin is going to have tomorrow. So how does neural network work in brief? And then maybe we can have another seminar specifically on that. But you can find this information anywhere on the internet. So basically, there's nothing to it. It's a complex mathematical construct, and it's as complex as you want it to be, depending on the application. But basically, you put the information in the network as numbers, maybe the RGB values corresponding to your picture. And then these numbers get crunched. I will not go too much in details. Will be associated to each one of these numbers weights and biases. And we're going to use an activation function. As I said, we don't have time to explain the math, but the important thing is that you're going to get an output out of it. And this output will, so you put the information, for instance, the problem as input, and you get as output, maybe 0 or 1. 0 is a cat, 1 is a dog. And how does the neural network know? Because once you put the numbers here, you're going to have a number in the output. How do you make sure that the neural network gives you the result that you expect? Because you want the neural network to tell you if that picture is a cat or a dog. Basically, that's the key. The key aspect of neural network is that you can use a large amounts of data. You feed it to the network as input, and you get an output. And then there is something called error function. So the error function will tell the network, "Oh, you got it wrong. That wasn't a dog. It was a cat." So we tell the network if that information, that calculation was wrong or right. By using a great number of data of pictures of cats and dogs, by telling the network that those, we give the answer. So we tell the network that those pictures are cats, maybe 1,000 cats and 1,000 dogs. By doing a process of readjustment of these weights and another value called biases, the network is going to adjust to it. So it does a process of readjustment. So in the middle of this, it will readjust. That is called training. You train the network so that after I have digested 1,000,000 pictures of cats and dogs, the network is going to know which one is a cat and which one is a dog. It's a bit complex to explain here. I'm probably going to explain next time, but that's what it does. But the key is that you need to have 1,000 pictures of cats, 1,000 pictures of dogs, feed it to the network, train it, and after that you can give a picture of a new cat or dog, a new animal, and it will be able to tell you if it's a cat or a dog. Sorry to repeat myself. Another thing we wanted to point out is the where is it? The dilemma of the Manx cat, because the Manx cat is a type of cat that is born without a tail. So if you train your neural network to recognize a cat based on certain features, well, a cat without a tail may be misclassified by the network as not a cat, or maybe a dog, who knows? So at what point the machine or the machine learning algorithms, the neural network is going to be smart enough to recognize these kind of features? Of course, that's only like an artificial neuron process that I showed you, but you can combine thousands of them to create a very complex neural network that learns from experience, and that network is going to be able to work autonomously once it's been trained, like a self-driving car. That once it's been trained with millions and millions and millions of data points, will know exactly what to do when it gets to these intersections and needs to decide what direction to go or how to take that intersection. The Tesla car works on the same principle, the autopilot. So basically, that's all I wanted to talk about in this session. And because otherwise we could go on and on forever. There's a lot of interesting information to be presented about neural networks and million different applications, but we're going to see them over the course of the next set of webinars in the coming months. And of course, you can send us an email to neuronet.blog. You can find our contacts on the website or through LinkedIn, and tell us what you would like us to talk about. We could talk about the uses of neural networks in space or in different other areas. We could talk about reinforcement learning, convolutional neural network. That is, it's like on the menu. There is the it's so vast that it really will take probably a lifetime to talk about machine learning and neural networks in all possible variations. So I thank you for the attention, and I think we can close here this first webinar from NeuroNet.blog. So thank you very much for the attention, and wish you a good evening. Bye then.